Hello, welcome to the ARA Solutions channel. In this video, we are going to be discussing an aspect of the kinematics of particles, and we're going to be solving a problem that borders on non-uniform motion, and it's going to be the second example in this series. That we're going to be solving this problem. The problem is about a particular particle that its acceleration is directly proportional to the square of time. The particle starts moving from position that is 24 meters away from the origin, and knowing that at time t equal to 6 seconds, x, which is the displacement, is 96 meters, and v, which is the velocity, is 18 meters per second. The first part of the question requires us to express x and v, that's the displacement and velocity, in terms of time, and then to find the distance, the velocity, and the acceleration when time is equal to 3 seconds. And to address this problem, we're going to first need to identify the variables that has been given to us. According to the problem, we're told that the particle moves with an acceleration that is directly proportional to the square of the time. That is to say, a is proportional to t squared. And also, when t is equal to 0, the particle is at the position x is equal to 24 meters. So we have that x naught is equal to 24 meters. Also, we're told that when t is equal to 6 seconds, we have the distance x is equal to 96 meters, and the velocity is 80 meters per second. So we have that x6, that's the displacement when the time is 6 seconds, is 96 meters, and velocity when the time is 6 seconds is 18 meters. The first aspect of the questions requires us to express x and v, that's the displacement and velocity, in terms of time, and that is to say xt is unknown, vt is unknown, and then we have to look for the distance, the velocity, and acceleration when the time is 3 seconds. That is to say x3 is not known, v3 is not known, and a3, the acceleration when the time is 3 seconds, is not known. Then having gotten all this, the next thing we have to bother about is the equations that we have that can be suitable for solving this problem. We have that velocity is equal to ds dt, rate of change of displacement with time is equal to velocity. We also have that the rate of change of velocity with time is equal to acceleration, that's at is equal to dv dt. Then we have at is equal to d2x dt square. That when we differentiate displacement twice with respect to time, we get acceleration. And finally, integral of v dv is equal to ads. So these are the four core equations that I use basically to address problems that has to do with kinematics of particles. And we're asked to look for velocity and displacement in terms of time. That's to find the equation that describes velocity and displacement. And meanwhile, we're given acceleration. They said we're told it's proportional to the square of time. That is to say our acceleration is equal to k times t squared, where k is a constant and we can use any symbol for that. So we have that a is equal to kt squared. The next thing is, and what do we have and what are we looking for? First and foremost, we have that a is equal to kt squared. We have a relationship between acceleration and time. So most likely we'll need an equation that can relate either displacement or velocity to be able to apply this to solve the problem. That is to say, we might need to look for an equation that either relates the velocity, acceleration, and time, or the displacement, the acceleration, and time to be able to evaluate them to get the necessary equations that we need to solve. In this case, let's say we want to first work out the velocity. So having known that we have acceleration in terms of time and we're looking for velocity, we need to find an equation that has these three components: as the velocity, the acceleration, and time. So if we look at this first equation, vt is equal to ds dt, what it has is component x, component t, and component v. There's no component a there, so this equation would not be useful to determine our velocity in terms of time. So if we go on to look at the second equation, you see that this second equation has acceleration at, it has v, and it has t. So this equation very likely is suitable for us to solve our problem. But just to look at the orders, the third equation has acceleration, displacement, and time, so it's not suitable because there's no velocity in there. And the last equation, it has velocity, displacement, and acceleration, there's no time, so it's not suitable, knowing that what we have, or what has been given to us, is a relationship between acceleration and time, and we're looking for velocity. So basically, we have identified the equation that we'll use to solve our problem. So the next thing is to solve. What we have is our equation, acceleration is equal to dv dt, and we're given a particular equation that relates acceleration and time. It is equal to kt squared. So what we want to do, we want to replace acceleration with its value, kt squared. And if we do that, we get another new equation, kt squared is equal to dv dt, which we obtain by putting kt squared in the place of at in the first equation. So having done that, we can multiply both sides by dt to get a new equation. Kt squared times dt is equal to dv. So basically, we can introduce our integration sign, and we can have thoughts as integral of dv is equal to integral of kt squared dt. So basically, we just integrate this side, both sides. We have that v is equal to kt raised to power 2 plus 1 divided by 2 plus 1. Just the basic way of doing integration of algebras. And we have our constant, integration constant a here. So if you simplify this, what you have is v is equal to kt cubed over 3 plus a. And this is our equation for velocity. Well, considering that we have boundary condition that was given to us, v6 is equal to 18. If we choose to impute this boundary condition into this equation, you see that we have two unknowns, k and a. So it's not the best time to introduce this condition, v6 equal to 18 meter per second, into the equation for velocity. The next thing, we want to progress to determine the equation for our distance x. We have the first equation that can use to determine velocity, which is v. Velocity is equal to differential of displacement with respect to time, and as well as a second equation that shows that acceleration is the second derivative of displacement with respect to time. The next question that we should answer is, what do we have that can help us with these basic formulas to determine our distance x? The first thing we have is that v is equal to kt cubed over 3 plus a. And of course, we have another equation that relates acceleration and time. So basically, we can use any of these sets of equations to address the problem. The first set is very likely more suitable because if we're using this, we have to just integrate once. If we choose to use the second equation that relates acceleration and displacement, we'll have to integrate twice. So to evaluate our distance x, we call out what we have. We have our vt is equal to ds dt. We also have our velocity equation is equal to kt cubed divided by 3 plus a. The next thing, we want to put the value of velocity into the place of vt, that's velocity as a function of time. So if we do that, we have that ds dt is equal to kt cubed over 3 plus a. Of course, that is gotten by just putting kt cubed over 3 plus a in the place of vt. And if we multiply both sides by dt, we're going to have another equation. So having gotten this equation, the next thing, we want to introduce our integration sign. So we're integrating both sides. The left-hand side with respect to x, that's ds, 1 ds, and the right-hand side with respect to dt. So if we do our integration by just following normal procedure, we have a new equation for displacement. And of course, if you're not familiar with how this is done, you just need to note that the part where we have t cubed over 3, we just add 1 to the power of t cubed to make it 3 raised to power 3 plus 1, and we'll divide that same expression by what we have, which is 3 plus 1, in this case is 4. While for the other aspects, integrating a with respect to time, what you get is at. And of course, we also need to add our integration constant, which is b. So if we simplify this equation, you're likely going to get a final equation that represents our displacement. So invariably, we answered the first part of the question, that requires us to find the velocity and displacement. The next thing, we want to introduce the boundary conditions that has been given to us to be able to eliminate the unknown constants, that's A and B, as we have in the equation. So we have our first equation for velocity, we have our second equation for displacement. Now we have that when time is equal to 0, displacement is 24 meters. So we have that S naught is equal to 24 meters. Other conditions that were given to us, we have that when time is 6 seconds, the displacement is 96 meters. And finally, when the time is 6 seconds, the velocity is 18 meters per second. So having gotten all this, next we want to begin to apply these conditions to be able to work out our integration constants a, b, and the constants of proportionality k that we have in the equations. So we start with the first one. So we have the S not equal to 24 meters, and we have our equation for displacement. So if we're going to put 24 meters in the place of x, and we're going to put 0 in the place of t. So if we do that, all the place of t, you see that we've put 0 and is equal to 24 meters. If we evaluate that, we have one simple equation that shows that b, our second constant of integration, is equal to 24. So next we're going to work with other boundary conditions. We have already used the first boundary condition, S naught is equal to 24 meters. And when we use that, we got our B to be 24. So next we're going to work with the next condition, which is when time is 6 seconds, X is equal to 96 meters. So we're going to put that into our equation for displacement. And once we do that, we put 96 is equal to K, T9 is 6 raised to the power 4 plus A times 6 plus B. And if we simplify that, we have a final equation, 96 equal to 108K plus 6A plus B. So this is a more simplified equation. And next we would want to consider the other condition that was given to us. The velocity when time is 6 seconds, which is 18 meters per second. And if we introduce that into our equation for velocity, v is equal to kt cubed over 3 plus a, we have that 18 is equal to k 6 raised to the power 3 over 3 plus a. And if you simplify that, you have 18 is equal to 72k plus a. So invariably, we have three core equations that we're going to be working with, and we have three unknowns. The first one is that b is equal to 24. The second one is for displacement, 96 is equal to 108k plus 6a plus b. And the third is 18 is equal to 72k plus a. So we're going to work with these three simultaneous equations and try to evaluate it to get our constants out of the equations. So the first equation we pick out is the most complex ones, which represent that of displacement. That's all components in it. And we have that b is equal to 24. So if we choose to put b into this equation in the place of b, what we have at the end of the day is 96 is equal to 108k plus 6a plus 24. And also we have our equation for velocity, which is equal to 18 plus 72k plus a. We can choose to make a subject of the formula to be a is equal to 18 minus 72k, and take back into our equation for displacement. And once we do that, we get a new equation for displacement, where we've put in the value of a in the place that it should be. And once we simplify this, we get another equation. So from this equation, we can work out our k by collecting like terms to have that k is equal to 1 over 9. So let's not forget that we've gotten a value for b, we've gotten a value for k. What is left is the value for a. So we have k is equal to 1 over 9, and we have our equation for velocity that has both a and k. So if we choose to put the value of k back into the equation for velocity and we simplify, we'll get that 18 is equal to 72 times 1 over 9 plus a. And if we work that out, you're going to get a value for a to be 10. So having done this, we discovered that we've gotten all our constant. K is 1 over 9, b is 24, and a is 10. So next we would want to put all this back into the equation to write them out properly. We have that a is equal to kt squared. So if you choose to put the value of k into your acceleration, you have that a is equal to 1 over 9 t squared. Then also, we have that v is equal to kt cube over 3 plus a. We already know the value of k, so the next we want to put in the value of a into the equation. And if we do that and simplify, we're going to have that v is equal to t cube over 27 plus 10. And finally, we have our equation for displacement, k times t raised to the power 4 divided by 12 plus at plus b. So if we put in all our variables k, b, and a into this equation and you simplify, you are going to get your final equation for displacement expressed in terms of time. So basically, we've gotten our three equations for acceleration, velocity, and displacement, all expressed as a function of time. So let's want to calculate our acceleration, velocity, and displacement when time is 3 seconds. So we have our equation for acceleration. We have that t is equal to 3 seconds. So we just put the value of t into the acceleration equation, and what you get after simplifying is 1 meter per second square. Then next you want to determine the velocity. The same way you have your time to be 3 seconds. If you put the value of t equal to 3 in place of t and you simplify, you are going to get v to be 11 meter per second. And finally, we want to determine the value of our displacement when time is equal to 3 seconds. So basically, if you put the value of time into the equation for displacement, you have that displacement is equal to 54.75 meters. So basically, we've gotten our three equations for acceleration, velocity, and displacement. I've gotten the answers for acceleration, velocity, and displacement when time is equal to 3 seconds. Now we're quickly going to see other variations that may occur. This question can come in different form. Like for example, we can choose to alter the conditions, give you different conditions for velocity rather than 0, the one we've done now. So that can make the question become another question entirely. Not only that, we can choose to give other instances of equation. Like for example, we can give you the equation for displacement and ask you to find the equation for velocity and acceleration. We can also give the equation for velocity and ask to find the value for the equations for displacement and acceleration. And finally, the equation can come with another form of relation for acceleration, velocity, or displacement entirely. So that in that case, you'll be addressing a problem that is very different from this one, such that the acceleration vary with time in a way that is very different from what we've seen now. So that's to say the forms that this kind of questions can take is limitless. Next, we're going to quickly look at another scenario. In this case, we're given the value for velocity. V is equal to t raised to power 3 over 27 plus 10. And we're given that when time is 0, displacement is 24 meters. And we are to express the displacement and acceleration in terms of time, and then find the distance, velocity, and acceleration when the time is 3 seconds. As you can see, this particular problem, we're given velocity. And it is a direct question. Velocity, find displacement, find acceleration in terms of time. The first thing to do is to identify what the question is requesting of you. In this case, we are looking for velocity. In this case, we are looking for displacement and acceleration in terms of time, given the initial condition. And we're also looking for the displacement, the acceleration, and velocity when the time is 30 seconds. So, of course, the next thing to do is to identify the equations that we have. And what has been given to us? Velocity. Which of these equations can be used to solve Which of these equations can be used to solve for the displacement and for the acceleration once we have the velocity, knowing that the velocity has a time component in it? So to look for displacement, we have to identify the equation that has both velocity and time, as well as displacement. To look for acceleration, we need to find the equation that has both acceleration, velocity, and time, because what we have is velocity in terms of time. So to evaluate for displacement first, we have our velocity given to us. We have the relation that relates velocity and displacement and time, which is v is equal to ds dt. So that is to say that to solve this problem, we have to replace the value of velocity in the original equation that serves as our formula. So if we do that, we have that t cube over 27 plus 10 is equal to ds dt. And Of course, you can reverse that to mean the s dt is equal to t cube over 27 plus 10. But this one now, for you to solve it, we multiply both sides by the t and we introduce our integration sign. And of course, you integrate. Once you integrate, you have your constant of integration present, in this case as a. Next, we have to introduce our boundary conditions. We've determined our equation. An equation has just one constant of integration a, and we're told that when time is 0, x is 24 meters. So if we put that into this equation, that's putting 0 in all the places we have t, and putting 24 in the place of x, which is our displacements, and you simplify, you have that a is equal to 24. So if you take the a back into the main equation, we have that x is equal to t raised to the power 4 over 108 plus 10t plus 24. And that's our equation for x. Next, we want to determine the acceleration equation. To do that, we have our velocity given to us. Next, you want to call for the equation that relates acceleration, velocity, and time, which is at is equal to dv dt. Note that we are picking this equation because it has the three components. That's v, it has t, and it has what we are looking for, which is acceleration. And the equation that was given to us is velocity as a function of time. And that's why we're picking this equation. So it's always a function of what has been given to you and what you are looking for. And that's what governs the kind of equation that you choose to work with. So for this case, we are going to put velocity in the place that we have v. So if we do that, we have that at is equal to d dt. That's differentiating the value of velocity with respect to time. For this case, it's going to be direct differentiation. We don't have to integrate because what we are looking for is at, and we've seen that acceleration is the differential of the velocity. So if we do that, you have that at is equal to 3t square over 27. And if you simplify further, you have your equation for acceleration to be equal to t square over 9. Next, we want to calculate the acceleration, velocity, and displacement when the time is 3 seconds. Just as we did before, you bring your equation for acceleration, your time is 3 seconds, you put it into the equation, and of course you evaluate and you get your acceleration to be 1 meter per second square. You do same for velocity, you put in your time is equal to 3 seconds into the velocity equations, and you get your v equal to 11 meter per second. And finally, you do same for displacement. You have your displacement equation to be is equal to t raised to the power 4 over 108 plus 10t plus 24. So of course, we're looking for this displacement when time is 3 seconds. So we'll put the value of 3 into all the places we have t, and we simplify, and we have x is equal to 54.75 meters. So basically, we've determined all our equations for acceleration, velocity, and time. We've determined the values of acceleration, velocity, and time when t is 3 seconds. And these are the answers that are required of us for that particular question. So now we want us to practice this problem. It's a bit different from the one we just solved. The difference between this and the previous one now, that we solved now, is that in this case we have our velocity to be a function of t cube over 3 multiplied by k and a. So there are two constants here. The two constants, one is k and the other one is a. Let's note that we have three boundary conditions in this problem. So basically, we're going to be working with all these boundary conditions to find our x, t, and a in terms of time, and to find their actual numerical values when time is 3 seconds. So if you can practice this on your own and you get the answers, this question is similar to the one we solved before. So the equations you are going to get are the ones you have in the previous problems that we solved. And these are the answers. We have our acceleration to be t square over 9, we have our velocity, and we have our displacement equation, as well as their values when the time is 3 seconds. So you work this out on your own and please practice it. It is once you can get the answer, you know you're already familiar with the procedure. And I think that will be all. I want to thank you for your time, and I hope that the video was illustrative enough. See you in subsequent videos.